Hello, and welcome back to the last section of Chapter 1, Scientific and Engineering Notation in Mthpt-103. So we took a break after talking about scientific notation, and we're going to continue on with engineering notation. So engineers like to be able to talk in numbers where they can use the abbreviations that you see here on the paper, like terabytes, gigabytes, megabytes, kilo, or even with it doesn't have to be bytes like in the computer world. It can be anything like meters or feet. It's not usually feet, it's usually the metric system. So in meters or kilometers, it can even be something really small. So when we talk about the rules, they're a little bit different than with scientific notation. In this case, where our numbers need to be between 1 and 1,000, so it won't be any bigger than 999 point something. And then our exponent has to be a factor of 3. So it could be a 3, a 6, a 9, a 12, and so on, or negatives of those same numbers. So we're going to go ahead and start working on the examples that we see in front of us. So we have 28,000, and we're supposed to write it in engineering notation. So because the exponent has to be a factor of 3, we move in groups of 3. So the decimal right now is at the very end. We're not going to think about moving in ones, we're going to move in chunks of 3. So there's a group of 3. Now if I moved again, I would not have a number between 1 and 1,000, so I have to stop. Now as far as knowing if it's a positive or a negative exponent, it still works. This was a number bigger than 0, so this is going to be a positive exponent. Now I did move 3, so this is a 3. I'm just not allowed to move in anything but 3s. So that's why I did it in one fell swoop. So we'll be counting by 3, 6, 9, 12 in this case. So here we have a number with a decimal back here at the end again to the right. We're again going to move in groups of 3, so 3, 6. Now I have a number between 1 and 1,000. 3.45 times 10, and remember I moved 3, 6, so it's a positive 6. So now I have a number smaller than 0, so I'm going to have a negative exponent. I'm going to move in groups of 3. There it works right there. It ends up between the 6 and the 6. It was a number smaller than 0, so it's a negative number. And I only moved one group, so that's just a 3. This is not in engineering notation. I don't have a number between 1 and 1,000, so I'm going to move a group of 3. Now you can see how we end up with much larger numbers in the front than we did in scientific. I end up with 975 times 10. It was smaller than 0, so it's negative, and I moved one group of 3. So those numbers have all been switched to engineering notation. So let's go down and look at the next ones. Here we're going to switch out of engineering notation and back to a decimal form. If my exponent is positive, I have to make my number bigger. If my exponent is negative, I make my number smaller. So here my number is positive exponent, so I'm going to make this bigger. I'm moving 3. The decimal is between the 7s. So 1, 2, 3. I have 2 gaps right here, so we're going to fill those gaps with zeros. So this is 57,700. This time I'm moving at 12. Again, I'm making it larger because it's a positive exponent. 4.94, we're moving 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 10 empty spaces, so I have 10 zeros. Three, 4, 5, 6, 7, 8, 9, 10. Put my commas in here. And there's my answer. So hundreds, thousands, millions, billions, so it's 4 trillion. Here I have 26 times 10 to the negative 6, so it's a negative, so it means make your number smaller. Right now 26, the decimal is at the end after the 6. We're going to move 6 places to the left. That makes it smaller. 1, 2, 3, 4, 5, 6. I have 1, 2, 3, 4 empty spots. 1, 2, 3, 4 zeros for those 4 empty spots. 2, 6. Again, I have a negative exponent, so I'm going to move the decimal 9 places. And I'm going left because that makes it smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 8 empty spots, so I have 8 zeros. And then 5, 9, 4, 5. Now what I didn't say up above, and I should have, we talked about when we started this that engineers like to use the tera, the giga, the mega, and so on. And so if they were using this A, instead of saying 28 times 10 to the third, they would say 28 and 10 to the third is a kilo. So then they would say 28 kilobytes or kilometers or kilo whatever they're talking about. On the next one, they would say 3.45 and 10 to the 6 is mega. So they would say 3.45 megabytes, 3.45 megameters, and so on. On this one, 10 to the negative 3 is milli. So they would say it's 6.6 millimeters or 6.6 milligrams or whatever you're working with. So they like to use this idea of words instead of using the base 10. And then the next one would be the same, 975 milli whatever it is. So that's why engineers switch over and do the groups of 3. So here we have some numbers we're going to just put into, we're going to do the math and then we're going to make sure their answers are in engineering notation. So just like in scientific notation, we put the like terms together. So we're going to do 35.5 times 420. Go ahead and use our calculators. Of course, mine just shut off right when I was about ready to use it. So on your calculator, go ahead and do 35.5 times 420 while I'm waiting for mine to come back up. So since I'm multiplying these, I'm going to add exponents. So that 6 plus 9 is 15. We're going to multiply that and put it in there. Of course, mine's being slow. 35.5 times 420. So I got 14910. Now this in itself is not in engineering notation. This number is bigger than 1,000, so we're going to have to get it switched over. The decimal right now is behind the 0. I'm going to move in groups of 3. So there's my group of 3. So it's going to become 14.91. Now this was a large number, so I'm going to make this be a plus, and I moved it 3, so that's a plus 3. So it's going to become times 10 to the 18th. This will be our final answer. It's now in engineering notation. Okay, here we have a division problem, so we're going to go ahead and divide 70.5 divided by 120. So I have 0.5875. We're dividing. When we divide, we subtract the exponents, and I'm subtracting a negative, so that's going to become a plus. So I have 0.5875 times 10 to the 6 plus 9 is 15. Now I'm not in scientific, this is not between 1 and 1,000, this first number, so I'm going to move in groups of 3. It's going to go to here, so it's 587.5. Now the original number was less than 0, so the exponent I'm putting out here is going to be a negative. I moved 3, so it's going to become times 10 to the 12th. So if you're not used to engineering notation, it looks a little weird having these numbers in the front be so much larger than what we're used to with scientific notation. But again, it's just for engineers so they can use the words instead of using the numbers. So the biggest we go on our chart here is 10 to the 12th. So on this last one, they would say 587.5 terabytes or things like that. And that's what a lot of our storage is now in. So that is engineering notation, and that finishes chapter 1. So work on your assignment. If you have questions, there's also a review for the upcoming test. So look at that and let me know if you have any needs. Thank you. Have a good day.